So, good day. Today's topic is from the operating system and memory management. Under the memory management, we are going to see contiguous memory allocation. So, what is contiguous memory allocation? Memory allocation refers to the process of assigning blocks of memory to various programs and processes running on a computer. The blocks of memory can be allocated continuously or non continuously. Based on this, we have two types of memory allocation techniques. What are they? Namely contiguous memory allocation and non-contiguous memory allocation. And here we will be talking about discuss on the contiguous memory allocation and also how to implement it in the operating system and its advantages and disadvantages. So, contiguous memory allocation, as the name suggests, allocates a single continuous block of memory to a process. The block of memory is allocated to a process is enough to hold the entire process. This means that the process can access all its memory locations without any interruptions. The image below shows the main memory allocates storage to three processes, which is P1, P2, and P3 processes using the contiguous memory allocation. And this is the main memory RAM, how this memory is contiguous memory is allocated to P1, P2, and P3. And in this image above, the process P1 is allocated three blocks of memory, which is F1, F2, and F3. And P2 is allocated two blocks of memory, which is P5 and P6. Sorry, F5 and F6. And similarly, P3 is allocated with one block memory, which is F8. There are some gaps in between the allocated memory blocks, which are at for F4 and F7. How these gaps are formed, even though we are continuously allocating memory. To understand this, we have to read about the fragmentations, and here come we have two types of contiguous memory allocation techniques, which is fixed partitioning, static type, and dynamic partitioning, which is variable type. In fixed partitioning and contiguous memory allocation, the fixed partitioning or static partitioning is a memory allocation technique where the main memory is divided into partitions of fixed size. Each partition can hold exactly one process. When a new process loaded into memory, it is allocated a partition of fixed size. And if the process is smaller than the partition size, the remaining memory in the partition will be wasted. If the process is larger than the partition size, it cannot be loaded into memory. The image below shows the internal fragmentation happening in the main memory during fixed partitioning. So, internal fragmentation is nothing but as the image above shows, one of the main drawbacks of fixed partitioning is internal fragmentations. So we can see that a process are not using the entire allocated memory. So what happens here is this will lead to a situation where even though there is enough total uh, memory available, it may not be possible to allocate memory to a new process because the available memory may not be contiguous. So dynamic partitioning in contiguous memory allocation. The dynamic partitioning or variable partitioning is a memory allocation technique where the main memory is divided into partitions of varying size. And depending on this size of process being loaded into the memory, when a new process is loaded into memory, it is allocated to the first available partition that is large enough to hold the process. If no such partition is available, the process has to wait until a partition becomes free. The image below shows external fragmentation happening in main memory during dynamic partitioning. And so the major issue with dynamic partitions is external fragmentation. In this image, we can see that there are some gaps in the memory after allocating and deallocating memory to various processes. This situation happens when a process is terminated from memory and its neighboring processes are still running. These gaps will add up over time as more processes are loaded and unloaded from memory. In such case, you need to restart the system to make the main memory free again. The advantages of contiguous memory allocation. The contiguous memory allocation techniques is preferred in some scenario due to the following advantages. Simplicity. Contiguous memory allocation is simple to implement and manage. The operating system can easily keep track of the memory blocks allocated to each process. And fast access. The entire process is stored in a single block of memory. No any calculations is needed to find the memory location of a process. So overall access time is faster. Low overhead. Contiguous memory allocation has low overhead as there is no need for complex data structures to manage memory allocation. Disadvantages of contiguous memory allocation. Even though contiguous memory allocation is simple and fast, comes with some drawbacks. Waste of memory. During contiguous memory allocation, there are gaps created in memory due loading and unloading of processes. This can lead to wastage of memory. Fragmentation. Contiguous memory allocation can lead to internal and external fragmentation. This reduces the overall efficiency of memory usage. Limited flexibility. Contiguous memory allocation is not suitable for virtual memory systems and in the case where processes are larger than the available memory itself. So, what's the conclusion here is the contiguous memory allocation is simple and fast memory allocation technique used by the operating systems. There are two types of contiguous memory allocation techniques called fixed partitioning and dynamic partitioning. The main drawbacks of the contiguous memory allocation is wastage of memory due to fragmentation. However, it is still used in the case of OS focuses on simplicity and speed over memory efficiency. That's all for the from the topic contiguous memory allocation. Thank you.